Combustible liquids can be identified by the white triangle at the bottom of the placard. The primary hazard associated with these materials is fire. Common flammable and combustible liquids are methanol, styrene, xylene, petroleum distillates, gasoline, and fuel oil. Materials in Class 4 are flammable solids and include Division 4.1 flammable solids, Division 4.2 spontaneously combustible materials, and Division 4.3 materials that are dangerous when wet. The primary hazard associated with these materials is fire, and water may be ineffective for extinguishment. The only common Class 4 material shipped by rail is molten sulfur, which is considered a flammable solid in Canada. Note that in the United States, molten sulfur is categorized as Class 9, miscellaneous. Class 5 materials are oxidizers, substances that support combustion. These materials can be reactive with organic materials and cause a fire. Organic peroxides, which can be shock and heat sensitive, are placed in Division 5.2. Ammonia nitrate fertilizer and sodium chlorate, both of which are powdered substances and simple oxidizers, are commonly shipped by rail. Class 6 materials are poisons and can either be liquids or solids. These materials can create a health hazard to humans and may be harmful to breathe if designated as a poison inhalation hazard, or PIH. A common poison transported by rail is phenol, which is a toxic liquid. Class 7 materials are categorized as radioactive. The vast majority of railroad radioactive shipments fall into the category of low specific activity materials, or LSAs. There are no radioactive materials among the top 25 hazardous commodities transported by rail. Class 8 materials are corrosive and can be either acidic or alkaline. The primary hazard of these compounds is tissue damage resulting from contact with the material. These materials may be shipped in specifically lined tank cars to resist corrosion. Splashed material may dry on the side of a tank car or around the fittings and be corrosive to skin. Common corrosive materials include sulfuric acid, sodium hydroxide, hydrochloric acid, and phosphoric acid. Class 9 materials fall into a miscellaneous category, which means the material presents a hazard but does not fall into one of the other classes. Ethylene glycol is primarily an environmental hazard and is a Class 9 material. Asphalt and molten sulfur are also categorized as Class 9 commodities in the United States, both of which are shipped at an elevated temperature. Tank cars and hopper cars used for hazmat shipments remain placarded the same way, regardless of whether they are loaded or empty. A loaded tank car may typically contain 90 tons of material. When the customer offloads the product, regulations require that the car be unloaded to the fullest extent practical. However, responders should always treat an empty tank car as if some product residue remains. The shipping papers should be consulted to determine whether a hazmat car is loaded or empty. No matter what material you are dealing with, it is imperative that you make contact with the CSX Hazmat Support Desk through the Police Communications Center in Jacksonville, Florida. CSX Hazmat Systems personnel are available to assist you in understanding the hazards of the materials we transport, and we can put you in contact with the product manufacturer and other technical specialists. When dealing with a rail incident involving hazardous materials, you are not alone. Help is just a phone call away. In this section, we have introduced you to the types of hazardous materials that are shipped safely each day by CSX Transportation. Understanding the 9 hazard classes and the risks associated with each is important in hazardous materials incident management. In the next section, we will discuss tank cars that are used to haul hazardous materials. Tank cars are used to transport the majority of hazardous materials. While there are a variety of tank cars used to ship these products, there are a few basic principles that you, as a responder, need to know about these containers. First, there is no front or rear of a tank car. There is an A end and a B end. The B end is where the handbrake wheel is located. The left and right sides of the car are determined by looking at the handbrake. Even the wheels are numbered from the B end as right side 1, 2, 3, 4, etc. By looking at the sides and ends of a tank car, a responder can find information about the car and its construction. On the sides and ends of the car initial and number will be stenciled. This number is unique to this car and is not repeated. The date the car was built will be stenciled on each side of the car, and the capacity will be stenciled on each end. The specification stencil can be found on both sides of the tank car. The parts of the specification stencil include the authorizing agency, the car specification number, special information about the car, the tank test pressure in PSI, and the material of construction. There are essentially two types of tank cars: general service cars that carry low-pressure commodities and high-pressure cars that carry compressed gases. Almost all tank cars are owned by leasing companies and chemical manufacturers and other shippers, not by the individual railroads. General service tank cars are the workhorses of the industry, making up about 70% of the tank car fleet. They are used to transport liquids and are typically rated at either 60 or 100 psi. Many general service cars are used to transport non-hazardous commodities, such as corn syrup and vegetable oil. Tank cars containing non-hazardous commodities will have no placards. General service tank cars are easily recognizable by the exposed valves and fittings on top of the car, and the bottom outlet that may be present. The fittings on top of a general service tank car include the liquid eduction line and vapor line, which are used for loading and unloading materials in a closed-loop system. The liquid line is the larger of the two and has an eduction pipe underneath which reaches the bottom of the tank. The vapor line is smaller and has no eduction pipe. Plugs or caps will be used to close these lines above the valve to prevent leakage should a valve accidentally open. Manways are present on most general service cars and are used for splash loading product or entering the car for inspections. Manways have gaskets and securing bolts that must be tightened in a crisscross fashion to ensure a proper gasket seal. The vacuum relief device present on many general service tank cars protects the car from developing a negative pressure. A spring-loaded valve inside the vacuum breaker allows air to enter the tank car during product cooling. A pressure relief device will be found on the low-pressure tank car and may be either a spring-loaded relief valve or a frangible disc-style safety vent. The spring-loaded relief valve is a reclosing type that is usually set to open at 75% of the working pressure rating of the car. A frangible disc is a non-reclosing device that is designated to fracture at 1/3 of the burst pressure of the tank car. Frangible discs are typically found in safety vents on cars carrying corrosive liquids, such as hydrochloric acid. Tank cars designated for corrosive liquid service display different top fittings than other general service cars. The safety vent replaces the relief valve. The fill hole replaces the manway, and the liquid and vapor lines are mounted to the main flange. Many general service cars have bottom outlets designed to offload product quickly from the car using gravity. Bottom outlet valves may be located internally and may be operated from the top, much like a fire hydrant, or be mounted on the bottom of the car. Bottom outlet valve handles must be secured in the closed position. While tightening outlet fittings is acceptable, fittings should never be loosened for bottom outlet leaks. In most cases, spill containment and product transfer are the best option. All tank cars can generate pressures high enough to cause injury if suddenly released. Keep your hands, body, and face out of the direct path of valves or openings. While hazardous liquids are transported in general service cars, high-pressure tank cars are designed for compressed gases, such as chlorine, anhydrous ammonia, and propane. High-pressure cars can be identified by the single protective housing on top of the cars that hold all the car's valves and fittings. High-pressure cars also do not have bottom outlets. The valves and fittings inside a high-pressure protective housing differ depending on the commodity transported. Note that some low-pressure products are shipped in high-pressure tank cars due to the increased protection of the valves and fittings afforded by the high-pressure tank car design. A chlorine tank car has a valve configuration like this. Inside the housing are 5 valves, 2 liquid lines that are in line with the center of the car, 2 vapor valves that are to the side of the housing, and 1 pressure relief device in the center. Each of the loading valves is sized at 1 inch and contains a plug to prevent leakage from the valve. The pressure relief device is a combination type that incorporates a frangible disc under a relief valve to prevent corrosion. Chlorine tank cars and their associated fittings are standardized and approved by the Chlorine Institute. Protective housings on high-pressure cars carrying propane or anhydrous ammonia typically look more like this, with additional valves and fittings inside. These cars have 2 liquid lines that are in line with the center of the car, and 1 vapor line to the side. The loading valves are usually 2-inch and may be ball or plug type. A spring-loaded pressure relief valve, usually set at 75% of the operating pressure of the car, will be present. A thermometer well is located on the car to allow the temperature of the product to be taken from outside the car. The thermometer well is a sealed tube that extends into the liquid space in the tank. The well may contain antifreeze. A sample line is present to allow the customer to take a sample of the product in the car and analyze it for quality prior to accepting the product. The sample line is a 1/4 inch tube with a needle valve and plug. Gauging devices are used during product loading to ensure the proper amount of material is loaded in the car. Older cars may have slip tube gauging devices. These gauging tubes are the most common leak points on high-pressure cars, with most leaks coming from the packing area. Newer cars use a magnetic gauging rod in a sealed tube. Magnetic gauging devices rarely leak. Tank cars have a number of construction features designed to enhance the safe transportation of hazardous materials. First, tank car shells are considerably thicker than many other containers in other modes of transportation. Depending on the pressure rating of the car, tank cars range from 7/16 of an inch for general service cars up to 3/4 of an inch for high-pressure cars rated for 500 psi, and high-pressure cars add an additional 1/2 inch of steel to the ends of the tank. This additional plate, called a head shield, helps protect these cars from impact in an accident. High-pressure cars that carry flammable gases are equipped with a layer of thermal protection to protect the tank shell from flame impingement. This layer may be sprayed on the tank or under a steel jacket. Many tank cars have an exterior jacket that protects the thermal layer or a layer of insulation. This insulation may be fiberglass, cork, ceramic fiber, or foam, and it helps keep the product temperature stable when outside temperatures may move significantly. Jacketed tank cars can be identified by the hoods over the saddles securing the tank. A non-jacketed tank car will have a visible saddle. It is important during damage assessment to know whether a car is jacketed. Since there is a layer between the jacket and the tank shell, dents that damage the jacket may not actually reach the tank, and may be merely superficial. Many jacketed tank cars contain external steam coils that are used to unload materials that require heating, such as asphalt. The coils are located between the tank shell and the jacket. The steam coil fittings project from the bottom of the jacket near the bottom outlet. Typically, these coils do not have caps or plugs. Since steam is used to heat these cars for unloading, water can condense in the coils and run or drip from these openings during transit. This condensation can be mistaken for product leakage. All tank cars are equipped with double shelf couplers. These shells help prevent couplers from becoming dislodged during incidents and allowing the coupler to travel up and impact the tank shell, causing a dent or puncture. On high-pressure cars, many of the valves in the protective housing have a safety feature called the excess flow check valve. This valve, located inside the tank car, monitors the flow of product through an external valve or fitting. If the flow through the fitting is excessive, possibly due to a fitting that is sheared off, the excess flow valve slams shut. Some cars, though, are designed to relieve product in transit. Tank cars that carry atmospheric gases such as carbon dioxide and argon have pressure regulating valves that relieve from time to keep the product pressure low and the temperature cool. This is a normal phenomenon for these cars. Tank cars that vent normally will have information stencils on the side of the car. While there are some specific tank cars that have different valve arrangements and unique features, they are rare. Most of the tank cars you will encounter fall into the general categories you've seen. While the valves and fittings appear basic, repairs can be quite complex. Unless you have been trained to do so, don't attempt to repair a leaking valve or fitting. And never climb on or around tank cars unless you have been given permission by the railroad. When you have a tank car problem, call the CSX Hazmat Support Desk at the Police Communications Center and talk to the tank car professionals. In this section, you have been introduced to the types of tank cars and their associated valves and fittings. You've learned about tank car jacketing and reviewed tank car construction features. In the next section, we will cover other types of rail equipment that responders may encounter. Tank cars are not the only freight cars that carry hazardous materials. Many materials are transported in other types of rail cars that present unique hazards and incident management issues. In a derailment, many types of cars may be involved. Being able to identify freight cars can speed up the incident size-up process. Boxcars transport materials that require protection from the weather. They are often used to haul materials such as automobile parts, lumber, paper, and appliances. When hazardous materials are transported in these cars, the internal containers may be bottles, boxes, drums, or intermediate bulk containers. In a derailment, the load may shift inside a boxcar, creating a crushing hazard to responders. Responders should not open a boxcar door unless a railroad official is present and has checked the car for damage. The refrigerated boxcar is an insulated car that has been designed to haul commodities that require low temperatures, such as produce, meats, fish, and juice. Refrigerated cars may be either cryogenic or mechanical. Cryogenic cars use dry ice as a coolant and have heavy insulation. Mechanical refrigerated cars use a generator and cooling system. This system typically runs off diesel. Mechanical refrigerated cars typically have diesel fuel tanks on board that hold up to 500 gallons. Intermodal containers allow shippers to move materials via different modes of transportation without changing packaging. Intermodal containers can be moved from ship to rail to truck. On the railroad, intermodal shipments are moved on flat cars or specially designed well cars. These cars are manufactured in various shapes and sizes to meet different needs. CSX intermodal shipments consist of trailers or containers on flat cars, or other specially designed cars. In either case, hazardous materials may be present in non-bulk containers such as bottles or drums. Intermodal shipments operate under the same placarding rules as highway trucks and may contain up to 1,000 pounds or 110 gallons of hazardous materials without placards. Always check the rail paperwork prior to working on intermodal containers or trailers. Bulk hazardous materials can move in intermodal tank containers. Tank containers have capacities of approximately 6,000 gallons, and most are constructed from stainless steel. Tank containers may be high pressure or low pressure and may be jacketed. While the valves and fittings on an intermodal tank may be similar to those found on a tank car, their location and appearance may be different. If you encounter an intermodal tank in an accident, contact the CSX Hazmat Support Desk at the Police Communications Center for assistance. Gondola cars are open-top cars used for irregular loads. They are most often used to transport coils of steel and scrap metal. As for hazardous materials, gondola cars, when lined with plastic and fitted with covers, are used for transporting hazardous solid waste, such as contaminated soil. Hopper cars are used for transporting dry materials in powder or granular form. Open-top hoppers are used for wood chips and coal. Covered hoppers are used for fertilizer, pigment powders, and other dry solids. Some covered hoppers are pneumatic and can be pressurized with air to assist in pushing the product out during unloading. Hazardous materials can be found in hopper cars. The two hazardous commodities most commonly transported in hopper cars are ammonium nitrate and sodium chlorate. CSX does not operate passenger trains for public use. However, public transportation companies do operate passenger trains on CSX tracks. In the event of an incident, CSX officials will coordinate response activities with the passenger train entity and local responders to manage the mitigation of the incident. In the event of a passenger rail incident on CSX lines, responders should contact the CSX Police Communications Center. In the event of a passenger train incident, timeliness of response is critical due to the potential need for medical treatment and evacuation of passengers. For safety reasons, passengers on a train should not be evacuated unless it is absolutely necessary to do so. If passenger cars are upright, it's recommended passengers stay inside until adequate shelter and transportation is available. Since equipment varies with each passenger rail entity, response agencies are encouraged to contact the passenger rail carrier in your area directly for emergency planning information. There are various other types of equipment that can be found on the railroad. Specialty freight cars designed for specific loads, track maintenance equipment, and high-rail motor vehicles all move along the rail. Incidents involving these types of equipment are rare, but should an incident occur, be sure that you have a railroad official with you before working on the equipment. And as always, be sure to call us. Freight could not move without locomotives to pull, push, and switch the cars. The modern diesel-electric locomotive is a far cry from the steam-driven iron horses of old. The newest locomotives have computer controls and digital displays that resemble the cockpit of an airplane. Many CSX units are equipped with auxiliary power units that reduce emissions during locomotive idling. Today's locomotives have some impressive statistics. They can weigh up to 420,000 pounds and develop up to 6,000 horsepower. They can be 65 feet long and 16 feet high. With that size and power, large quantities of liquids are needed for lubrication, cooling, and fuel. Up to 380 gallons of cooling water can be circulating on a locomotive. Antifreeze is not added to cooling water. A biodegradable corrosion inhibitor gives the water a greenish color. In freezing weather, if the engine must be shut down, the water will be dumped to prevent freezing the engine block. Over 400 gallons of motor oil keeps the diesel engine lubricated. The electric traction motors also hold a small amount of lube oil. Many people think when they hear the hum of a diesel locomotive that the diesel engine supplies the power to the wheels and moves the train. Actually, the diesel engine drives a generator that supplies electricity to the electric traction motors behind each wheel, and the motors move the train. And it takes a lot of electricity to move a train weighing several thousand tons. Most locomotives run on direct current or DC power. DC-powered locomotives can develop up to 600 volts at 800 amps. Newer locomotives with alternating power or AC systems can develop up to 23,000 volts. If you come in contact with this level of energy, serious injury can occur. Batteries and capacitors store this energy in the locomotive. Locomotives can carry up to 5,600 gallons of diesel fuel. This fuel is stored in a tank under the locomotive. This tank is not compartmentalized. There are fill holes and sight glasses that show when the tank is full on each side of the tank. Also on each side of the tank is the emergency fuel cutoff. This red button can be pressed by responders if the locomotive must be shut down and crew members are not available. When the button is pressed, a solenoid valve at the top of the fuel tank will close. Fuel flow to the diesel engine will cease and the locomotive will shut down within 1 minute. An identical button is located in the cab of the locomotive behind the engineer's seat. Keep in mind that pressing this button simply shuts off the diesel engine. It does not turn off the electric system, which can be charged for some time by the batteries or capacitors. On a locomotive incident, it is imperative to seek the advice of the locomotive engineer or another railroad official. Because of the high voltages present, water cannot be used in all compartments of the locomotive. Spraying water onto energized electrical equipment in a locomotive can cause electrocution or other severe injury to responders. Have a railroad official present when you work on a locomotive incident, or treat the locomotive as energized. And always contact the Police Communications Center in Jacksonville if you are called to respond to a locomotive incident. The people who make up CSX Transportation work hard to ensure the trains moving through your community do so safely. Many of you may never have the opportunity to use this training in the field. However, should an incident occur, trained CSX personnel are available to assist you in managing the incident safely and effectively. In this section, we have discussed railroad equipment such as freight cars and locomotives. Locomotives can contain over 5,000 gallons of diesel fuel and can generate over 23,000 volts of electricity. Keep in mind that hazardous materials can be shipped in any kind of rail car. By federal law, as a common carrier, CSX Transportation cannot refuse to accept any hazardous material that is properly packaged, labeled, and supplied with a correct bill of loading. If you have additional questions about hazardous material safety on CSX, visit our website at www.csx.com. Thanks for your time, and have a safe day.